So, we all know that everything is made of atoms and that atoms are mostly empty space. But if that's the case, then how come I'm not falling through the ground right now? Why won't I actually be able to go through platform 9 3/4? The answer has to do with Pauli's exclusion principle. Pauli's exclusion principle says that no two electrons can share the same characteristics. For two electrons in an orbital, almost every characteristic is the same. The only value that can be different is spin. But what does spin actually mean? Let's ask Otto Stern and Walter Gerlach. Their experiment sent a beam of silver atoms through a magnetic field and measured the pattern of electrons on their way out. If spin didn't affect anything, they would see a singular random cluster of electrons. However, two distinct beams of electrons emerged from the magnetic field. The positive spin electrons with spin plus 1/2 were traveling in line with the magnetic field, and the negative spin electrons with spin minus 1/2 were traveling in the opposite direction. Electron interactions with the magnetic dipole don't explain spin, but it's the only way we can measure it. But that's not entirely accurate because electrons aren't things exactly, and they don't spin. People might think they're particles or waves because they might behave like particles or waves, but they're actually state vectors, which have wave functions. See, we're not entirely sure we know what exactly electrons are, but we know what they do. The wave function of a particle determines the probability that it has certain characteristics. Particles like bosons, with even wave functions, have the same y value for opposite x values. This means that they are interchangeable. Fermions like electrons have odd wave functions. Putting in opposite x values will give you opposite y values. This means that you can't interchange them. In fact, the only place where you can enter an x and a negative x and get the same value is at probability 0. Great Scott! In an actual orbital, the first electron could be either positive or negative spin. But if the second electron tries to enter, that space within a magnetic field is already occupied by the first electron, so it has to go in the other direction and have the opposite spin. Once you have the two electrons aligned against each other, you've completed the magnet. The completeness of the two electrons acts as a repellent to more electrons from a different material, kind of like a force field. Boils down to 1. Electrons have an innate spin. 2. This spin interacts with magnetic fields. 3. This interaction cannot be the same for two electrons in an orbital. And 4. This phenomenon creates a force field that separates different types of matter. So, it turns out that I can't science my way into Hogwarts. But I did learn along the way that the way we approach electrons should be the way we approach everything else. Electrons are more than just particles or waves. I'm more than just a teenager or a girl. The sooner we realize that we are more than the sum of our parts, the better we'll be able to empathize and connect with each other. And that's even more magical.